Consider a random permutation of numbers 1, 2, 3 till 3, 1, 4, 1, 5. Let A be the number of fixed points, that is, elements that remain in their original position, and B the number of non-fixed points. The question says to find what's the variance of B minus A. So we are given a sequence of numbers, and we are asked uh, that what will be the difference, what will be the variance of the difference between the non-fixed and fixed points. So what this means is, let's say if the number is 1, 2, 3, we'll have in total 3 factorial permutations of this sequence. So we can write this as 1, 3, 2, 1, 2, 3 is already done. So 2, 1, 3, 2, 3, 1, and so on. Now, if you notice here, in this permutation, 1 is in its original position. So this is a fixed point. 1 is a fixed point here. Similarly, 3 is in its original position here. So this is a fixed point. So this is what the question means when it says the number of fixed and non-fixed points, and we are asked to find the variance of B minus A, where B is the number of non-fixed points and A is the number of fixed points. So let's start. We have n. Let's let n be equal to 3, 1, 4, 1, 5, which is the upper limit, the last number of the sequence. We define A as the number of fixed points, the permutation, and B as the number of non-fixed points. Now, since each number is either fixed or non-fixed, we have A plus B will be equal to n. So we can write B minus A as n minus A minus A. So we have replaced B with n minus A. And this gives us B minus A as n minus 2A. So let's take a small example and see how this plays out, and then we'll come back to estimating the variances and covariances. So let's take a small example with n equals 4. The number sequence is 1, 2, 3, 4. A is a random variable of number of fixed points. Let's say the position 1 is fixed. We don't care about 2, 3, 4. Let's count the permutations. So fixed 1, now arrange 2, 3, 4 any way you like. We'll have 2, 3, 4, 3 digits can be permuted in 3 factorial equals to 6 ways. So we have 6 permutation here. 1, 2, 3, 1, 2, 4, 3, 1, 3, 2, 4, 1, 3, 4, 2, 1, 4, 2, 3, and 1, 4, 3, 2. Each of them have 1 fixed in its original position. So if you look at the permutations, first all are in their original position, 1 and 2 in their original position, 1 and 4 in their original position, and so on. Notice that across all, 1 is always in its original position here, as we had assumed. Now, we define an indicator variable for each position, which is given by capital I, which is equal to 1 if position I is fixed and 0 otherwise. So you can consider this a Bernoulli random variable, which is equal to 1 or 0, 1 with certain probability p, which we will calculate just in a few steps, and 0 probably 1 minus p. So if any given position I is fixed, their indicator is 1. If it's not, then it's 0. Now in this above example here, every one of the above permutation has I1 equal to 1. That is, the first position here is fixed, which means the first position has the same digit as is in its same position as is in the original position, which is the original sequence of numbers. So I1 equal to 1 because the number in position 1 is fixed, that is, it is in its original position. So what's the probability that I1 equal to 1? We have 6 permutations, as we just saw, where the first position was fixed, and in total we have 4 factorial permutations, which is 24. So 6 divided by 24 equals 1 by 4. This is the probability that the first position is fixed. Now, if you generalize this, we will have n minus 1 factorial over n factorial. So n factorial is the total number of permutations. And if we fix any one of them, we'll be left with n minus 1 positions. And those n minus 1 can be permuted in any way which we like. This will be n minus 1 factorial. So this gives us n minus 1 factorial over n factorial equals 1 over n. So probability that I is equal to 1, which is a given ith position is fixed, is given by 1 over n. Now we come to the variance part. we have to calculate the variance of b minus a. So recall that adding a constant does not affect variance. Also, scaling by a constant scales the variance by the square of that constant. So we have variance of b minus a. We replace b minus a with n minus 2a, as we saw in the previous step. We had replaced b with n minus a. This gives us n minus 2a. Now this would expand into variance of a plus b. If you recall, variance of a plus b is given by variance of a plus variance of b plus twice of covariance of a and b. So variance of n, this would be 0, it's a constant, plus variance of 2a would be 2 squared times variance of a. So when a random variable is multiplied by a constant term, the variance scales by the square of the constant. So this gives us the 4a term. Of course, there would be no covariance because this is not a random variable n. So our task reduces to finding the variance of a. So we had defined a random variable, which was the indicator variable I for position I, given by I equals to 1 if the position I is fixed and 0 otherwise. So this means that our random variable A becomes the sum of all of these indicator variables. So A is the random variable of all of the fixed positions. So let's say we have 1, 2, 3, 4, and we have position 2 fixed, position 4 fixed. This and this are 0. So we have two fixed positions. So this means that A is equal to 2, which is also the sum of this indicator variables here, which is 1 here, 1 here, sum of I, which is equal to 2. Now you have to compute the expectation and the variance of I in order to calculate the variance of A. So we know that I is a Bernoulli random variable, and we saw previously that probability that I is equal to 1 was given by 1 over n. For a Bernoulli random variable, so the expected value is given by p. So in this case, where p is the probability that the indicator is equal to 1, so in this case expected value equals to 1 by n. Similarly, the variance of a Bernoulli random variable is given by p times 1 minus p. So if we plug that in, p is equal to 1 by n, variance becomes 1 over n times 1 minus 1 over n, which is this here. Now coming to the covariance part. The covariance between I and ij. For any two random variables, the covariance can be written as the expected value of the product of the random variables minus the product of their expected values. So in this case, the random variables are I and ij. The expected value of I is equal to probability that I equals to 1, which is equal to 1 by n. Similarly, ij is equal to 1 by n. So what we need here is this part, the expected value of the product of the random variable. So what exactly is this I and I times ij? So let's take a look at this table here. The first column is I, second is ij, and the third is the product. So we put in the values 0, 0. When it's both these indicators are 0, the product will be 0. When one is 1 and the other is 0, it will still be 0. And it'll be 1 when both are 1. So this I times ij is itself a random variable, which is 1 when both I and j are 1, which means that the expected value of I times ij is the probability that I equals 1 and ij equals 1, which means what exactly this means? So I equals 1 and ij equals means two positions are fixed, the I and jth, and the remaining n minus 2 positions can be permuted in n minus 2 factorial ways. So what's the probability of this? We have n minus 2 factorial ways of permuting the remaining positions, and in total we have n factorial permutations of all of the positions. So the probability becomes n minus 2 factorial over n factorial. This is equal to 1 over n times n minus 1. So for I not equal to j, the probability that both positions are fixed is given by 1 over n times n minus 1. So now we have this part in the covariance equation, we have got this part, expected value of I times ij is equal to 1 over n times n minus 1. And we already had this part, expected value, which is 1 over n for each of them. So 1 over n times 1 over n becomes 1 over n squared. Subtracting this and simplifying, we get the covariance equal to 1 over n squared times n minus 1. Now coming to the covariance, the variance of A. So variance of A, recall that A was the sum of I, indicator variable I, from I equal to 1 to n. The variance for sum of random variables is equal to the sum of their individual variances plus twice the covariance between all the pairs. So this is what we have written here. The sum of variance I from I equal to 1 to n plus twice the covariance between II and ij. Now, so we'll calculate both of these parts individually and then we'll sum it up. So what's the sum of covariances? The sum of variances. So if you recall, the variance which we had calculated was 1 over n times 1 minus 1 over n. This came from the fact that for a Bernoulli random variable, the variance is p times 1 minus p. For each of the II, this would be the same, which is 1 over n times 1 minus 1 over n. And in total, we have n of these parts. So this becomes n times 1 minus 1 over n. This gives us n times 1 over n times 1 minus 1 over n. This gives us 1 minus 1 over n. Now the second part is the covariances. So we had calculated the covariance in the previous step just over here, which was 1 over n squared times n minus 1. And how many terms would this be in total? The number of terms would be the number of pairs which we have. The number of pairs would be nc2. So we have n in total, and we have to calculate how many pairs would this make. So this would be nc2. We have 2 from here originally in the equation. So 2 times nc2 times the covariance term, 1 over n squared times n minus 1. Simplifying this, we get 1 over n, the sum of covariance part. Therefore, the variance becomes the variance part, which is 1 minus 1 over n, plus the covariance part, which is 1 over n, and this simplifies to 1. Now, time for the final answer. The variance of b minus a is 4 times the variance of a. If you recall, we had calculated this initially, which is equal to 4 times 1, which is 4. So this is the final answer. The variance of b minus a is equal to 1. Thanks for watching, and drop in the comments below if you have any questions, or if you would like to cover any other specific topic, or if you have any other approach of solving this question. I'll see you in the next video.